it shouldn't have survived. By all the laws of orbital mechanics and thermodynamics, the object known as 3I Atlas should have been ripped apart. In July, a silent alarm triggered across the global astronomical network. Something had breached our solar system. It wasn't an asteroid from the asteroid belt, and it wasn't a comet from the Oort cloud. It was an interstellar intruder racing through the void at speeds that made our fastest spacecraft look like they were standing still. But that speed wasn't the problem. The problem was that as it dove toward the sun, it began to behave in ways that defied every model we have for how a comet is supposed to die. It started glowing with an intensity that blinded sensors. It shifted colors violently. It vented material in the wrong direction. And then just as the data began to make sense, it vanished behind the solar inferno. For weeks, silence. The scientific community held its breath. Had the sun swallowed it whole? Did it shatter into a billion invisible fragments? Or was something far more complex, perhaps even artificial, happening behind the curtain of our star? We now have the answer, and the truth is far stranger than a simple rock drifting through space. Through the combined eyes of a fleet of spacecraft scattered across the solar system, from the orbit of Earth to the dusty surface of Mars, we have pieced together the story of a cosmic survivor. This is the story of an object that was cooked by the galaxy, tortured by the sun, and lived to tell the tale. To understand why this object is so terrifyingly unique, we have to look at the warning signs it gave us before it even reached the sun. In late summer, the Swift Observatory, a telescope usually tasked with hunting the most violent explosions in the universe, turned its ultraviolet gaze toward this tiny point of light. What it saw was a catastrophe in motion. Usually comets warm up slowly. They are dirty snowballs that gently hiss gas as they approach a star. 3I Atlas didn't hiss, it screamed. The data from Swift showed it was dumping water and dust at a rate that was scientifically impossible for an object of its size, unless it was undergoing a catastrophic collapse. It was shedding mass so fast that astronomers were convinced it was disintegrating right in front of us. It was glowing bright enough to confuse automated tracking systems, shining like a dying star rather than a cold rock. This was the first anomaly. Why would a rock that has spent millions of years in the freezing dark of interstellar space suddenly explode with such violence the moment it touched our neighborhood? Before we could answer that, the object plunged into the kill zone. Perihelion, the point of closest approach to the sun. This is where the story usually ends for small comets. The tidal forces rip them apart and the heat vaporizes what's left. Ground-based telescopes on Earth were blinded by the sun's glare. We were flying blind, but we weren't not watching. We have eyes everywhere. The solar fleet, spacecraft like SOHO and Stereo A, built to monitor solar storms, caught the intruder on its death dive, and they captured a metamorphosis that has never been seen before. As 3I Atlas hit the solar wind, it changed its skin. It entered the encounter red, the color of ancient, dusty, organic tholins that coat objects in the outer dark. It emerged blue, a brilliant violet blue. This wasn't a trick of the light. The intense solar heat had stripped away the comet's outer layers, boiling off the dust and exposing a fresh, volatile, icy surface underneath. It was shedding its armor in real time. But even as it survived the fire, the mystery deepened. The trajectory didn't match. As it came around the sun, the object was moving faster than gravity alone could explain. This non-gravitational acceleration is the spark that ignited one of the most heated debates in modern astrophysics. When a rock moves differently than gravity dictates, it means something is pushing it. In the case of comets, it's usually outgassing, jets of gas acting like rocket thrusters. But 3I Atlas was small, and the push was significant. This is where the whispers began. Harvard astrophysicist Avi Loeb and others pointed out that the physics were bordering on the inexplicable. They noted a sunward jet, a stream of material fighting against the solar wind. Loeb suggested that if the natural explanations failed to align, we had to remain open to the unnatural. Could this be a probe? Could the acceleration be artificial propulsion? It's a seductive idea. An autonomous craft using the sun for a gravity assist, firing thrusters to correct its course. It would explain the survival, the speed, and the weird behavior. But science is about evidence, not just elegant theories. And just as the alien speculation reached its peak, a radio telescope in the South African desert turned on. The MeerKAT array is a beast of radio astronomy. It didn't look for heat or light. It listened for the radio signature of molecules. And what it heard was the death knell for the alien spaceship theory. MeerKAT detected the unmistakable, screaming signature of hydroxyl, water. This was the smoking gun. 3I Atlas wasn't a dry metallic hull. It wasn't a solar sail. It was a wet, volatile, icy body venting oceans of water vapor into the vacuum. The artificial acceleration was actually a perfectly natural, albeit violent, rocket effect. The sunward jet was simply the comet's day side, boiling off explosively, pushing the nucleus backward and away from the sun. It was a comet, but calling it a comet is almost an insult to how strange this thing actually is. Because once we knew it was natural, we had to explain why it was so weird. James Webb Space Telescope data began to paint a picture of the object's chemistry, and it was wrong. All wrong. It had extreme levels of carbon dioxide, far higher than local comets. It had unusual metal signatures. It was behaving like a chemical factory on overdrive. The consensus now is that 3I Atlas is a processed object. It's not a pristine time capsule from the dawn of creation. It is a victim of cosmic radiation. Imagine drifting between stars for hundreds of millions of years. There is no atmosphere to protect you. You are bombarded by high-energy cosmic rays, day in and day out. This radiation doesn't just hit the surface. It penetrates. It breaks chemical bonds. It cooks the ice. It turns simple molecules into complex, reactive, explosive compounds. A3I Atlas is a radiation-cooked survivor. It was a battery waiting to be discharged. When it finally hit the heat of our sun, that stored chemical energy was released all at once. That explains the brightness. That explains the explosion of activity. That explains the blue shift. We weren't watching a normal comet. We were watching a billion years of interstellar damage unwinding in a few weeks. But perhaps the most haunting observation of this visitor didn't come from Earth, and it didn't come from space. It came from the surface of another world. While we were scrambling to track the object, the geometry of the solar system lined up perfectly for an observer on Mars. The Mars Reconnaissance Orbiter swung its high-resolution cameras to track the nucleus, but down on the surface, in the dust of Jezero crater, the Perseverance rover looked up. For the first time in the history of astronomy, a robot on the surface of another planet imaged an interstellar object. In the raw images, it's just a faint smudge, a ghost drifting against the background stars. But the implication is massive. We have reached a point in our civilization where we are no longer earthbound observers. We have a sensor network that spans planets. We tracked this intruder from 3 different worlds simultaneously. So where is it now? 3I Atlas survived the solar encounter, but it won't be staying. It is currently racing back out into the dark on a one-way ticket to interstellar space. It is passing Jupiter one last time, a tiny, battered traveler bidding farewell to the giants of our system. It leaves us with more questions than answers. It taught us that the space between stars is not empty, but filled with objects that have been sculpted, cooked, and altered by the galaxy itself. It proved that our detection systems are getting good enough to spot these things before they vanish. And it reminded us that while it probably wasn't aliens this time, the line between a weird natural rock and something artificial is getting blurrier the closer we look. The universe is throwing rocks at us, and for the first time, we are catching them. If you want to keep following these mysteries as we peel back the layers of our solar system, make sure you're subscribed. There is plenty more darkness to explore.